13.4, the reactivity series. From the bottom to the top, from the least reactive metal to the most reactive metal. So gold is considered as the least reactive metal among these metals. Less reactive means more stable. More reactive means very not stable. Gold is very stable because it is not reactive. So now gold is gold. 200 years later, gold is still pure gold. Iron is not stable, therefore it will easily react with oxygen and become iron oxide, or we call it as ferrum oxide. So what does it mean by not stable? Not stable means reactive. About stable, stable means not reactive. Gold is stable. If it is burned in the air, what will happen to the gold? Gold will still go. It will not react with oxygen and become gold oxide. Iron is not stable. Iron is more reactive. If iron burns in the air, what will happen? Iron will become iron oxide, a new compound. Chemical equation is always on the left hand side is less stable, and it will tend to become more stable condition. Actually, there is not just all this metal here, but there are other metals which you can put in, for example tin, nickel and platinum, etc. Things to remember about the reactivity series. It is a list of metals in order of their drive to give up electron and form positive ion with stable outer shell. The stronger the drive, the more reactive the metal will be. What does it mean? It means, so potassium is more reactive, aluminium is less reactive. So potassium will have stronger drive to drive out the electron and become ion, potassium ion. And aluminium has less drive to get rid of the electron. So you look at gold and iron. Gold is more tend to be in the form of element, more stable in the form of element. And iron will be more stable in the form of compound. Okay, another example. Iron plus oxygen become iron oxide. Mercury plus oxygen become mercury oxide. Can you tell me iron oxide is more stable or mercury oxide is more stable? The answer is iron oxide will be more stable. Mercury plus oxygen become mercury oxide. Actually, mercury oxide is not stable. And if you provide a little bit of heat to mercury oxide, it will actually go backwards and become mercury, and oxygen will be produced. So this one is more stable. This one is not stable. So answer these two questions. Now questions. Iron oxide and mercury oxide, which one will be easily extracted from its ore? Which means which one is possible? Is it possible iron oxide by heating will become iron plus oxygen? The answer is no, because iron oxide is very stable. Okay, mercury oxide by providing heat, it will become mercury and oxygen. The answer is yes. So number 4, the more reactive the metal, the what difficult it is to extract. It is to extract from its ore. So is it possible to extract iron from its compound other than iron oxide? The answer is it is possible, but very difficult, very tough. So answer number 5. The next topic is comparing the stability of some metal compound. So they undergo thermal decomposition, use heat to decompose and see how is it. So number 3, but reactive metal have more stable compound. If the metal is reactive, so no matter how you heat it, it will still in the form of that compound. Means it won't be easily decomposed. So now we go to these two examples, this sodium and copper. Can you tell me which one is more stable? The answer is copper is more stable in the form of element. More stable in the form of element. So when you heat the copper compound, what will happen is it will tend to decompose and become something else. Sodium, it is more reactive, so when you provide heat to the sodium compound, because it is reactive metal, so it is more stable in the form of compound. So when you heat the sodium compound, for example sodium carbonate, there is no change. When you heat sodium hydroxide, they will have no change because they are already stable. When you heat sodium nitrate, it will decompose little bit. So it means sodium compound as a reactive metal is more stable compound. Let me explain. Sodium is not stable, so it tends to become compound. So sodium compound is stable. So when you heat it, it is still that sodium compound. The 3 examples given in the textbook, sodium carbonate, you heat, no change. Sodium hydroxide, you heat, no change. Sodium nitrate, you heat, a little bit change to sodium nitrate. Little bit only. What about copper? So copper, it is stable. Copper compound is not stable, means easily decompose, 很容易分解，被分解, easily decompose. The 3 examples given in the textbook is copper carbonate. If it is heated, what will happen? It will be decomposed to copper oxide. Okay? Copper hydroxide, because copper hydroxide is not stable, so it will become copper oxide. What about copper nitrate? Copper nitrate will become copper oxide as well. So in the form of compound, copper compounds are not stable. Therefore, they are easily decomposed. So again, come to this table, you will see what? You will see the top one here, sodium, potassium, these two. Calcium also lah, but potassium, sodium especially, when they are in the form of compound, they are very stable. Page 3, the general rules for thermal decomposition. So the lower a metal in the reactivity series, the more readily its compound decomposes when heated. Metal carbonate, metal hydroxide, metal nitrate, when you provide heat, they will become something else. They will be decomposed, except sodium and potassium. So sodium carbonate, potassium carbonate, sodium hydroxide, potassium hydroxide, when you provide heat, they won't be decomposed. They cannot be decomposed. While sodium nitrate and potassium nitrate, when you heat them, they will become sodium nitrate plus oxygen. They won't be decomposed like other metal nitrate and become oxide, nitrogen dioxide and oxygen, because these two metals, when they are in the form of compound, they are very stable. Actually, the third most reactive metal, calcium, also very difficult to be decomposed. calcium carbonate, for example. When you heat calcium carbonate, it will become calcium oxide. Yes, but you must provide very high temperature to decompose calcium carbonate. And for your information, calcium carbonate actually form our bone, our teeth, reef, eggshell. They are all actually formed by calcium carbonate.